you need to know, okay? And if you don't have a study sheet, right, you better really know your stuff, right? I mean, some of you don't need it, but I would say most do, okay? And so this is our last, second last test, right? So we've got this one, and then February 1st is our last test. And I'll tell you exactly the topics that are going to be on there. It's not going to be the whole year. I'm going to tell you what's on there. And the group that is here today, you're going to already get, I'm going to give you a printed copy of that review, which you're going to start on Tuesday next week, all right? So that way you have something to go by. I will, however, also give you another one. That one I haven't received yet. So this group, for example, if you could just stop by on, because you're in on Thursday mornings, right? Before you leave, just swing by my room and take that one with you so that you have, you have it already on Thursday and Friday. So you have like, and then the whole weekend, of course, to get ready for February 1st, right? So I would suggest you do that. That way you have your own printed copy. Somebody's saying something. I'll do the attendance in a bit. Okay. Average. Well, after this test that we're writing, I'm going to post an updated class report, okay? If that's what you were asking, Patrick, I'm not sure if that's where you were getting at, okay? Okay, so get this test review out. I posted it again today as a PDF. If you're joining from home, yes, I'll do the attendance in a bit. I want to make sure you're awake, right? So I'll do it randomly at any time, any point, okay? So the first couple are true and false. We're not going to get through the whole thing today, but I will skip some of them so that we can get to the ones that matter, okay? Or at least you have an example to go by. Right? So make sure you write down stuff, right? Have your study sheet right next to you. And let's go through this, okay? Use a diagram to the right and circle the best response. Side QR is opposite to angle P, right? Angle P is right here. So maybe what you want to do is like go out and say like, is side QR, right? Is that opposite to angle P? And that's true. Right? Is side PQ the longest side? From P to Q, what do we call that? That's our hypotenuse, right? So yes, that is true. Absolutely. R squared is equal to Q squared plus P squared. R squared is your hypotenuse, right? And that will be equal to these two squared and added, so that is true as well. Right? Hypotenuse squared is equal to leg squared plus leg squared. Okay? And that's what, right? This is a leg, this is a leg. When you're talking Pythagorean theorem, that is true. Okay? Cosine of Q, cosine of angle Q is equal to Q over R. Stop before you do anything. Please do this for yourself. Cosine means, right, you need the adjacent and the hypotenuse here. Okay, so go find Q, which is here. That would make this opposite to Q. And then this would be hypotenuse, it always stays, and this is the adjacent. So adjacent should be P, right? You should have P there. And then R. So this is false. Cosine of Q is equal to P over R. Okay? This is true, but that is false. Next, tan of Q And so we're again talking about angle Q, so these labels still apply. Tan of Q is Q over P, opposite over adjacent. That's true, right? Because tangent is opposite over adjacent. So Q over P is true. Tan of P is Q over R. It's still TOA, but now you're looking at P. So P is here. That would make this opposite, and it would make this adjacent now. Okay, so that's the latest. So opposite would be P. It should be P over Q. This is not P over Q, so that's false. Tan of P is P over Q. Okay. Side Q is adjacent to angle Q. First of all, let's find Q. No, there wasn't an AC today. This I just gave you. It's posted as a PDF, okay? You're just going along with this. You don't have to hand this in. Okay, side Q is adjacent to angle Q. If this is angle Q, this would be the adjacent side to Q, right? So this is false. It should be side P, right, is adjacent to angle Q. That one I will leave to you for you to do. I will post the full answer key later today. I just wanted to go over some, and I will give you some class time to work on the rest as well. Backside, they're asking solve for the missing side. So Pythagorean theorem there. Pythagorean theorem there. Okay. C, I put 2 stars on to remind me to go over that with you. This is not a right triangle. Okay. Not a right triangle. Split. Okay. Split in half. So we take, they want to know this here, the height of it basically. Take one of these and just redraw that. This is x, this is 60, and this is going to be what? 90 divided by 2, which is 45 feet. That's where this is a little trickier than the rest. You have to split it. X is one of the legs of this triangle, right? Because this is the hypotenuse, this is leg. So leg would be square root of hypotenuse squared minus the leg squared. $15.75. That's 39.69 feet. There, I did that with you. No, this is not an AC, Jordan. I don't know if you're still asking. It's just going over the review, the test review that I handed out yesterday already. This one I wish I had more examples of. I just have one, but you can go back in your notes and we did this, okay? Show whether or not this triangle is a right triangle. So basically what you have to do is show that left-hand side is equal to right-hand side. Okay? So we know that hypotenuse squared is equal to leg squared plus leg squared, right? There are 2. Hypotenuse is 62, so you square that. Then you grab one of the legs, you can go 48 squared and 36 squared. Okay? And figure out what those values are. This would be the left-hand side of the equation. This would be the right-hand side. So make sure showing whether or not a right triangle is right or not, or a triangle is right or not, you do this, okay? 62 squared is 3844. And then I'm going to figure out what the other side is. That's 3600. And now you have to do something that's important. These are not equal, right? Can you tell they're not equal? So you have to do this. They're not equal. Therefore, not a right triangle. That's it. So our goal is to show that left-hand side is equal to the right-hand side. Like if they are, boom, it is a right triangle. But if they're not, then obviously you just conclude. But you can't just tell me if it is or not without showing the work. Okay, so I was told again today that I'm a little bit fast, so I'm just gonna leave that there for those of you who are writing this down. Go for it. Okay. These ones you should be very comfortable with by now. Okay, so I'm gonna, for now, leave that. Again, here is, right, just filling in the right two values that go with each. And in this case, there are two triangles, so you gotta watch out what you're doing there. I will do a couple, random. Okay, let's do cosine of E, for example. Always remembering that we have this to help us out, right? You know that these two sides go with that trig ratio, or that this trig ratio function goes with these two sides, right? So it's a two-way reminder. Cosine of E is ka, right? A over H. Go find E. Go over here. E is right there. Then you go opposite, adjacent, hypotenuse. That's based on E, right? So cosine is A, so it's 4.2 over hypotenuse, which is 7. Done. Okay. If you have multicolored pens or markers, maybe that would be a better way to do labeling, right? Because, and I'm going to use this one, right? The dark one goes with these three labels. But if you make a red mark here, based on that, this would be opposite and adjacent here. right? They flip based on, so, right, you know, it's, and hypotenuse is always the same. It's always the same. So we could do the same one with this, right? Have a red mark there and have a different color here. And so based on this one, this is the opposite. And this would be the adjacent. And this is the hypotenuse. It's always the hypotenuse. But based on this angle up here, this is now the opposite. And this is the adjacent, right? So it depends on where you're located. So let's say tan of n. Tan calls for opposite and adjacent. Go find n, it's over here. Opposite, which is 4.2. Right? Opposite's the red one because you're in the red dot. And adjacent is 5.6. And so forth. So you fill in the rest. I will give you the answer key later on. You can look at it. Okay, next. Let me see if there's an item of interest. Yes, this one here I will do. Can you go to question 4? Question 4 is the solving one, where you have to draw, label, and then solve. There is? You know what? Yeah, it's true. So anyways, the first number 4. That's what happens when you copy and paste. Yeah. I have a lot of different reviews. Okay, sign of it. So it says draw, label, and solve each triangle. This one is the hardest one, the first one here. I will tell you, like, when you have something like that, right? Draw your triangle somewhere out here, and it has to be a right triangle. The angle, it could be a number. In this case, it's a letter. Put it right down here. Why not, right? And then sign tells you, right, you're using so. So that means that the top number is opposite, the bottom number is hypotenuse. So opposite would be 4, hypotenuse would be 5. Like that. If you want to call this, call this letter, give it a letter B because you're going to solve for the angle, go for it. If you want to call this C, not needed, but we can do that. So right here, I'm going to rewrite it so that you recognize it, right? This is 4/5 like this. Turn that into a decimal. 4 divided by 5 is 0.8. The only thing left to do here is to find that angle. So A is going to be sine inverse of 0.8. Okay, so you take the inverse of that, sine inverse in this case, come up with an angle. So try that, make sure you know how to do inverse. And that's 5313 degrees. So whenever you start off, you can use that to solve for what's left. So this is 53. That in there is 5313. If you want to label it right on the diagram. Okay. You can now easily find B, so that's my next move. Take away 90 from 180. Take away 5313. Angle B. And remember, you can call it whatever you want. And that's 36.87 degrees. Also something that I need to know, right? So you found A right from what they were giving you at first. You found B by using the sum sum of a triangle is equal to 180. That's the property that I'm using to find that third angle. And what should we call this? We can call that x, you can call it lowercase b, whatever, okay? We can use Pythagorean theorem, the Pythagorean theorem, to find that last side, because you have 2 out of the 3. So b is one of the legs, right? So you're going to have to take the hypotenuse and subtract the other leg from it. That would be 9. B is equal to 3. So that's one where the angle is unknown. Okay. Same thing happens here. And this is different. This is where you're trying to solve for a side. So you're going to have to cross multiply and divide there. Okay. And I mean, I've done so many, like even if you just go back this week, we've done so much review on that. Watch any of those videos and it will refresh your memory. Let me just see here on the back. Six. Is there just one 6? I hope, yeah. Go to question 6 there for a moment. It says find the indicated angle and state if it's an angle of elevation, depression, or if it's neither, whatever you want to do, right? So how would you do that? Well, let's solve first. This is the angle that they want. Label it based on that. This is opposite. Across the 90, you have your hypotenuse. And I'm going to label the adjacent, but I don't care. Okay, so I'd rather not. So it's opposite hypotenuse, you're thinking. So, right? Set it up here. Sine of letter C, angle C, is opposite over hypotenuse. Come up with a decimal. It's not always 0, but most of the time it is. That's 0.5741. Right? Whenever you have sign of a letter and then 2 numbers, your instinct should tell you, okay, I'm going to turn that into a decimal, and then I'm going to use the inverse to find the angle. .04 degrees. Make sure you round to 2 decimals if you want full marks. Make sure you include the degree symbol if you want full marks. Okay, so here is the kicker now. Is this angle of elevation, depression, or neither? What do you think? I'm going to ask the class. You only have 3 options, right? You would say elevation. Anybody else? Arabella, you're shaking your head. Is that neither? Okay. Anybody else? Raghav, what do you think? Not sure? Okay, how about this? Instead of me telling you, elevation is always between the horizontal and the line of sight going up. Depression is always between the horizontal and the line of sight going down. Neither, I'll give you some examples here. If an angle is there, that's nothing. Right? A lot of students think that's a depression, but really the depression would be here. Okay, so neither would be that. or, oh, sorry. Yeah, sorry. So this is not the angle of depression. That would be a neither example. And so think of this, is there a horizontal? Like if you had a horizontal here, and this would be the line of sight looking up, you could say that this is elevation, but this is neither, okay? Okay, it's none of the two, okay? Okay, let's do this one here. This is the one I want, this angle, so I'm situated here, opposite. There's no 90 here, but that's where it's supposed to be. Opposite, I don't care. Hypotenuse, adjacent. A and H, it's cosine. I have room here, so cosine of, let's use that letter, that's a Greek letter for theta, right? Cosine of angle is going to be adjacent, so 201 over 322. I turn that into a decimal. 0.6242. Theta is going to be cosine inverse in this case of 0.6242. And let's see if that gets us somewhere. That's 5138. Round it. It's 51376. And that rounds to 38. Boom, there you have it. 31.3. What's that? 31.3. 51. 51, yeah. Yeah, it's kind of small, right? And yours is blurrier than my screen here for some reason. What angle is this? Anybody? I don't bite, you know. I won't like knock you down if you get it wrong. What's that? I'm going for this one here. This angle right here, what is it? Elevation? Would you agree? Okay, we agree. I agree too. It's elevation. Because there's a horizontal and a line going up. So this is a little deceiving, right? Because I always make it go, those three examples, I make it go up to the, from left to right kind of thing. Doesn't matter which way, as long as you have a horizontal and a line going up, that's the angle of elevation. C is the same thing, finding the angle. Just watch the wording. What angle does the ramp have to have for the following measurements to be true, right? There's only one angle that will make these two measurements happen. There's only one. And that's the one you find by using the inverse, okay? So there's no secret there. There's no difference in solving. I think, let me just, I just want to see what's back there. Yeah, it's a bunch of word problems. So I will actually do one of the word problems on the back there. But just before we go, before you're working on your own, there's one again that is a full triangle, an oblique triangle. You need to work with the right triangle. You can't do the whole thing. So you need to split this again. Okay, split. So somewhere, right, I might do that here. Just make a small version of it, where this is 32. This is R for rafter, right? These are the rafters of your house. right? Under your roof, there's a bunch of like rafters holding it, making sure it doesn't collapse on you when there's lots of snow on there. And this will be split in half, right? You divide that in 2. So it's 25 inches. So this is the one you'd use to calculate the length of that rafter. Okay? I will do one because I haven't done a solving yet using trig. So here, it's adjacent and hypotenuse that you know, right? So it's a cosine example. Cosine of 32 is equal to adjacent over the hypotenuse, which is r. Put the 1 here. In this case, you need to multiply down, divide up. So it's 25 times 1, which is just 25, divided by cos of 32. .48. That's the downside of always making new reviews. I have to rekey everything. But I make them better, that's why I start changing them up. I will give you the answers to the rest. So let's go. I will let folks at home write it down. I encourage you to go through my notes as well. Don't just go by this review, okay? Certain terms, certain things that I've mentioned will come back. How about we do question 4 under, right? This is the extended answer section. So question 4 there. This is the back side of your document. A wheelchair ramp is going to be installed outside the front doors of a school. The plans call for an angle of 5 degrees and a ramp that is 8 meters long. The horizontal distance of the ramp cannot be longer than 8.2 meters. Sketch the situation. Okay, so you basically, if this is the school here, right? And it's kind of like high up on something. There's a ramp that's going to be built towards like the level ground, right? So this is your ramp, and you know that that ramp is 8 meters long, and right, this is going to go straight down because you need a right triangle. The horizontal distance of this ramp will be 8.2 meters. 8.2 meters. Or, okay, I know some of you will have done this differently, and you're probably going to be right. So you have 2 ways of doing that. I'm going to see what the angle would be if this were the case. If you actually stretched out and made it 8.2. Oh, that cannot be. Sorry, never mind. What happened here? Yeah, I know you're going to tell me, Mr. Dirksen, the hypotenuse is shorter than the leg. Yes, yes, yes. So that's why this cannot be there. Let's put the 8 there. We know that the ramp is 8 meters. And let's make this 5 degrees here. Okay, that's 5 degrees because that's the plans call for an angle of 5 degrees and a ramp that is 8 meters long. So those are facts. Okay, they're gonna be there based on the plan. Okay, so sketch a situation. We've done that. Way to go. Will the ramp fit? Justify your answer. So we're gonna figure out if it's an 8-meter ramp and you can only have a 5-degree angle, because if it's steeper than that, then people can't get up there, right? If it's slippery or whatever, it's an issue. So we're going to figure out x, and then we will justify whether or not it will fit. If this is longer than 8.2, it will obviously not fit. But we know it cannot be because, right, this ramp should be the longest part of all. So let's go ahead and see what we can do. This is the adjacent, and this is the hypotenuse here. Okay? Adjacent hypotenuse, it's cosine. Okay, so let's go solve. Cosine of angle is going to be adjacent, sorry, 5 degrees, not A, is going to be x over 8. Okay? X is going to be 8 times cosine of 5 degrees. You can go times here if you want, put an x there. And let's see what we get. 8 times cosine of 5, 7.97 meters. So our answer is yes, it will fit since it is less than 8.2 meters horizontally. Right? And there you have it. Okay, that's all I'm going to do today. The rest is up to you. You can do the review, the AC review that we did a couple of days back. Most of you handed that in, but if you haven't done so, do it anyways. And I will post the answer key to the rest later on. Okay.